of complex numbers, Bhavna?
I have, yeah. I think, I mean, I tried a few of the first lessons on Khan Academy, so I know a little bit about imaginary number I, but yeah, that's it pretty much.
Okay, yes. So before we discuss complex numbers, we will have to discuss imaginary numbers. And before we discuss imaginary numbers, let's talk about real numbers.
Okay.
Okay, so real numbers, the set of real numbers is denoted by the letter R, and all the numbers that we have studied till now, all the numbers like natural numbers 1, 2, 3, they are natural numbers. Then we have fractions, we have decimals, right? We have negative numbers, we have irrational numbers, right? All the numbers that actually exist in real life, they are all real numbers.
Yeah.
Yep. So square root of 7. Then a problem arises when we have square root of a negative number. For instance, we have square root of negative 36. So here the problem comes. So how do we evaluate the value of square root of negative 36?
Okay, I might know this. I think it's like an imaginary, the imaginary, so I equals to -1, so it'd be like I square root of 36, right?
Absolutely, absolutely.
Okay.
Okay, yeah. So what happened was that to evaluate square roots of negative numbers, we have created an imaginary number which is I, and this imaginary number I, and it's called iota. It is a Greek letter. This I, it's a Greek letter. It actually does not have this dot on the top of it, but we conventionally we use this dot. But the Greek letter iota, it does not have a dot, and we use this letter to denote square root of -1. Okay, and it does not exist in real life. Like there is no number that is actually square root of -1. That is why it is called imaginary. Imaginary means something which does not exist.
Yeah.
Okay, so now this helps us to evaluate the square roots of negative numbers. So what we have to do is, this can be written as negative 36 can be written as -1 times 36. Okay,
Yeah.
and then we can separate these terms out, square root of -1 times square root of 36, and we just saw that square root of -1 is I. So this, in place of this, we'll write I, and square root of 36 is nothing but 6. So the answer is 6I. So square root of -36 equals 6I. And this 6I, we call it as imaginary number.
Okay.
This is also imaginary number. So if I write some imaginary numbers, they can be 4I, they can be -8I. This is also imaginary. It can be fractional as well. So these are all imaginary numbers.
Okay.
Now let's talk about complex numbers. Complex. So Bhavna, if I combine something which is real and something which is imaginary, so see, I'm writing something real plus imaginary, then we get something which is complex. Obviously, because you're taking something which is real, which exists in real life, and something which is imaginary, which does not exist in real life. So this is a complex thing. So then we get a complex number. For
I have a
instance,
question.
yes,
So,
yes,
for
ma'am.
example, you said like -8I is an imaginary number, but wouldn't that just be -8 times negative square root of -1? So it would be like um, negative times negative. Wouldn't that be a positive square root?
No, no, no. See, there is a difference. What if I ask you what will be the value of negative square root of -64?
Okay, okay,
So if you try to evaluate this one, so you'll get this negative sign is outside the square root.
okay.
So that will remain as it is. And the square root of -64 will give you 8i.
Yeah,
Okay. And if you have just square root of negative 64,
that's just 8i.
that will be 8i.
Okay.
Okay. Now a real number, if I take any real number, for instance, any real number 4, and any imaginary number 8i. So this complete thing, this is now a complex number. Okay, this is a complex number, and we use letter Z. We use letter Z to denote a complex number. So one more example I will take. Z equals negative 3 minus 11i. This is again a complex number. Here, see, Bhavna, a complex number will be made of real number and imaginary number. So it will have a real part. This is the real part, and this is the imaginary part.
Yeah.
And this is a complex number. So there are few terminologies. We'll do some terminologies. First is REZ. You will see this very often. REZ means what is the real part of Z. So real part of Z is negative 3 here. And then you have IMZ. This means imaginary part of Z, that is negative 11 here. Okay. So this is all about introduction of complex numbers.
Okay.
All right. One very important concept that you should know. If I write, let me just write a real number. If I write just a real number, negative 11, would you say that this is a complex number, Bhavna?
No.
Okay. Because, okay, why?
Because it's like it's a real number.
Okay. Now, here is the difference between imaginary number and complex number. This number is a real number, right?
Hmm.
But if I add 0 times I to it, so I'm just writing it 11 plus 0 times I. Can I write negative 11 equal to negative 11 plus 0 I?
Yeah,
I've
because
just,
0 times anything equals 0.
yes, 0 times anything equals 0. So basically, I have not changed it. I've just added a 0 to it.
Yeah.
Okay. So this is actually a complex number. Now this becomes a complex number. This is a
Oh,
complex number
okay.
which has imaginary part 0, which has,
Okay.
okay, imaginary part 0.
When you write imaginary part, do you just write the coefficient or do you also write the I?
No, just the coefficient. It will be
Okay.
just the coefficient of I.
Okay.
That's the imaginary part. Okay, so here, from here, there is a very important concept, Bhavna, that every real number, every real number is a complex number as well. The
Oh,
only difference is that here the imaginary part will be 0. Okay,
okay.
all real numbers are also complex numbers. All right, this is very important.